So we are going to move forward into section 30-2, and we're going to title this Area of Triangles. Remember, I'm too lazy to write the word, so I draw myself a little triangle and put an S in there, implying more than one. So we're going to work our way through the concept of a few different area formulas. And in doing so, we need to remind ourselves of how to identify a couple of different types of triangles. So let's jump right in to an example. So what I want you guys to do is I actually want you to draw a rectangle on your paper. And I know it's going to be a rectangle because I'm going to put in that right angle kind of all the way around. And it doesn't look like a square, it looks like a rectangle. So we're going to call this guy a rectangle. Now, yesterday, we said that the area of our rectangle was base times height. Where we described our base and our height, they have to come together at 90 degrees, they have to be perpendicular. And that was pretty easy for us to process. But we're playing with triangles now. So what I'm going to do with this this rectangle, is I'm literally going to cut it into two. And I want us to focus on the area of that bottom triangle, which, by the way, would be the area of the top triangle as well, because I'm literally cutting this rectangle in half. I'm just doing it on the diagonal. So the area of a triangle is equal to base times height divided by 2, because we're cutting our rectangle in half. That's not so bad. And I know you guys have done this before. What is important is that we need to be able to identify the base and the height. And remember that they have to be perpendicular. We have to see the height coming in at a right angle to the base. So we're going to walk through a couple of poorly drawn triangle examples before we move forward to another couple of examples that are going to ask a little more work from us. So let's just draw ourselves a nice, beautiful, or as beautiful as we can draw, right triangle. And let's say that the left-hand side is 15 inches and the bottom is 18 inches. Our job is to find the area. And I'm hoping that we can agree that we have a base and a height because they form 90 degrees, they're perpendicular to each other. So for the area, that will be 15 times 18 divided by 2. And being your human calculator, that is 135 inches squared. You guys okay with that? Any questions on that? Yes. Yeah, instead of dividing by the 2, if you'd prefer to type times 1/2, that's totally fine. Absolutely. So when I say base times height divided by 2, some people write that as 1/2 base times height. It's the same thing. So I don't want to mess with you if you've seen it other ways and you're making it look familiar to you. Any other questions on that one so far? Okay, I'm going to change this problem. I'm going to add in another piece of the puzzle What if I had given you this length right here, which is the question mark? If I had given you that length, you wouldn't have needed to use it in the area. But if I gave you all three lengths, could you find the perimeter? Perimeter is adding them all up. So let's do one more like this. Let's do a right triangle. And I'm going to label this guy as a 3, 4, 5 right triangle. And I have two tasks for you. I need you to find the perimeter, and then I need you to find the area. And we are going to pretend that these are measured in centimeters. There we go. So I'm going to freeze the screen. I want you guys to find both the perimeter and the area. If you're watching the video, you'll see me do it in real time. And I'll come back to my in-person people in a second. So give me a thumbs up when you're ready and you want to start comparing your work to mine. Or if you're not ready, but you still want to look at my work, that's fine with me. So some thumbs ups. Seeing some thumbs. Okay, let's take a look. Did you guys find a perimeter of 12? 3 plus 4 plus 5, making sure I added correctly because I didn't use my calculator, but you never know. Now notice how those units are listed as centimeters. Perimeter, the units remain the same. Just add them up. Centimeters is the distance you walked around the edge of that triangle. Area, now for area you have to identify the base and the height. And the base and the height come together at a right angle. So 3 times 4 divided by 2 should be looking at 6 centimeters squared. Area is squared. You guys good? Any issues? Next example. Let's see. Now this one I am purposefully not drawing as a right triangle. So I've got a lot of stuff going on in this one. I'm going to zoom in so you can see the numbers maybe a little bit better. There's 2 things I want us to find. Perimeter and area. So remember, perimeter is talking about the walking distance around the outside edges or segments that make the figure. So we're looking at 15 plus 23 plus 18, and I'm totally using a calculator. 56 feet. Not so bad. The 12, because it's not on the outside walking edge, has nothing to do with perimeter. The 12 is what we need for area. When we look at this problem, we need to recognize that we have a base of 23 and a height of 12 because those are the 2 sections that are perpendicular to each other. So our area will be 23 times 12 divided by 2. That will be 138 feet squared. So you have to think about that base and that height, they have to be perpendicular to each other. Any questions on that example? So we're going to transition to a special type of triangle, and we're going to reason our way through how to find the area of this guy. So we're going to draw this triangle in a very particular way. I want you guys to notice that I'm going to put a single tick mark or dash on the left and the right hand side. That means the left and the right hand side are the same length, they're congruent. Do you guys remember, it has a special name, the name of a triangle that has two, not three, two congruent sides? It starts with an I. Isosceles. So an isosceles triangle has two congruent sides and technically two congruent angles. Right now, we're going to emphasize the two congruent sides. So I'm going to tell you that the left is 10, and we're going to do miles. This is going to be a big triangle. Well, that means that the right-hand side is also 10 miles. They're congruent. Oh, there we go. I'm going to tell you that the bottom is 6 miles. And I think we can find perimeter really fast. But our area is going to be a little bit of a problem for us. We don't have a height. There's nothing perpendicular to any of the sides. So we have to actually build the height of this triangle. I'm not sure if this is going to show up as red, but it's intended to be red. Okay, what I need you guys to do is to split the difference between the two congruent sides. So when I say split that difference, I want you guys to go up to the angle that is between the two congruent sides, and we are going to drop a perpendicular straight down. And I'm going to focus on the left-hand triangle. If you want to focus on the right hand, go ahead, it's the same. But I'm going to focus right here on my left-hand triangle, and I'm going to draw that guy again. So the left is 10. Our height is showing up. And here's what's interesting. By us dropping down a perpendicular line segment, we're going to split this angle in the top, so we have two congruent triangles. That also splits the 6. So it's technically called a perpendicular, because it makes 90 degrees, bisector, because it's going to cut it into 2 pieces. So this little yellow triangle now has a base of 3. We have to go solve for our height. And we're going to use Pythagorean theorem to do that. So we're going to take 3 squared plus h squared, the 2 legs of this skinny little right triangle, equal to 10 squared. We're going to solve for our height. So I'm going to square my numbers, subtract off the 9, and then take the square root. You guys doing okay? I really don't know the exact value of the square root of 91, but my calculator does. So I'm going to type that in. And I'm going to round that to be just about 9.5. So we need to pause. Remember what we did. We took our isosceles triangle and we dropped in a perpendicular bisector. We cut it in half at 90 degrees. And we used that half of the triangle with Pythagorean theorem to find the height. So we now know our height. For our area, remember that area is base times height divided by 2. Well, our base was 6, because that's what connected to our perpendicular. Our height is now 9.5, and the 2 was always the 2. Our area is 28.5 miles squared. A little bit tiny. 28.5 miles squared. So this one took a little extra work for an isosceles triangle. Questions on that? Let's do another one of those real quick, and then we're going to do one last type of triangle. So let's talk about our isosceles triangle. I'm actually going to tell you that the left and the bottom are going to be congruent. And I'm going to tell you that the left side is 7, and let's do meters. And I'm going to tell you that the right-hand side is 10 meters. On this one, visually it just looks different because I've kind of rotated that triangle. Find the two sides that are congruent. Find the angle between and drop in a perpendicular bisector. And then focus on just one triangle. That perpendicular bisector, that's our height. We gotta go find that in just a second. But our base becomes a 5 on that little skinny triangle because we cut the 10 in half. We cut the triangle in half. You guys doing okay? Any questions? Okay, so it is Pythagorean theorem time. H squared plus 5 squared equals 7 squared. And remember that the hypotenuse, the biggest of the sides in that triangle, has to be on its own. So when we square our values and subtract off our 25, we'll have h squared equal to the square root of 24. Take our square root. We're looking about 4.9 with rounding. Do you have any questions on that so far? Because that's not our answer. That's our height. For our area, we need to do our base of 10 times our height of 4.9 divided by 2. Questions on that example? Okay. I'm going to turn the page unless you guys still need to see that. We have one more type of triangle to play with. And we'll do a quick summary. So the next type of triangle that we're going to play with has all three sides congruent. Do you guys remember the name of that kind of a triangle? It starts with an E. Yes. This is an equilateral triangle. It has three congruent sides, and by the way, three congruent angles, all at 60 degrees. Okay. There's actually a formula that talks about how to find the area of an equilateral triangle. And where it comes from is it comes from breaking it into two triangles with a perpendicular bisector, and so you can use trigonometry and it works its way through. I'm going to be a bad math teacher and I'm just going to give you the formula. I'm not going to show you how it came to be because there's a weird little piece to it and it's going to take too much time. So the area of an equilateral triangle is the square root of 3 over 4 times a side squared. So the square root of 3 is the top of the fraction. The 4 is on its own. It's not inside the root. It is the denominator of the fraction. And then our side squared. Would someone give me a number, any number, to put on this equilateral triangle? 6. Okay, we're going to go with 6. And let's go with 6 kilometers. It's going to be a big triangle. I only have to give you one side because you know all three sides, right? This guy's equilateral. So let's find the area of this particular triangle. We're going to do the square root of 3 over 4 times 6 squared. That's it. But that's not it, because we need to make sure that we can type this. Now, I'm going to show this a couple of different ways. I'm going to leave it with the square root in it, and I'm also going to provide the decimal because I want you to be able to have both options available. We know that 6 squared is 36. And in this particular example, 36 and 4 can reduce. Four goes into 36 9 times. And this becomes 9 root 3 kilometers squared. I don't really know what 9 root 3 means. So I'm actually going to show this with my calculator. I'll move my calculator away in just a second, but I want you guys to be able to see this. If we do the square root of 3, I have to make sure that I close my parentheses on the root so that the calculator stops trying to take the square root of any other number. Times 6 squared, and then divided by 4. That's about 15.6. I kind of like the 15.6 kilometers squared better because I have a better concept numerically of what that means versus 9 root 3. I don't feel like I know what 9 root 3 means. But you can type these. Pretty easy, right? We can do this. So I want to do a really quick summary. area of a triangle. Base times height divided by 2. If we have an isosceles, we need to cut the triangle in half, find the height with Pythagorean theorem, then find our area. We have an equilateral triangle. It has its own unique little formula. You don't have to go find the height. We are good to go.